Yes, sir.
Yeah. So we have completed up to basic system model. Today we will start with dynamic models. So in mechatronics or in any measurement and control system, we are designing the model to predict output based on the input. So the function of any model is to predict your output. Okay. And this output are predicted based on the input available. Okay. So in any mechatronic system, we deal with static model and dynamic model. Okay. So basically in a static model, once your steady state is reached, okay, so your output, let's say Y, will correspond to your input X. However, in dynamic model, your output and input changes with time. Both output and input changes with time. All right. So if you talk about any dynamic model, so basically your output Y is a function of time and X is a function of time. Okay. So in order to express a system, it is generally represented by a differential equation with derivatives with respect to time. All right. Okay. So before going into the detail of any dynamic system, we should understand the component of dynamic system. So a dynamic system will have two basic components. One is input and another one is dynamic response of the system. Dynamic response means the output you are getting and or how your system is responding. So in line to this, first we will cover dynamic response system. So we have two types, natural and forced and steady state and transient. So these are the two major type of dynamic responses. So coming back to first natural and forced. So first, what is natural response? So in natural response, there is no input and the output will vary uh, with respect to time. So let's have an example. So you have a container with a hole at the bottom, okay, and it is filled with the any liquid or water, let's say. So under the action of gravity, you are not providing any input, you are not forcing this liquid to come out, but under the action of gravity, this liquid will come out of this point, okay, B, with a discharge of Q, and P1 and P2 are the two differential pressure that is encountered. So P1 minus P2 is equal to RQ that you have covered in basic system model, that is hydraulic resistance. Okay, and Q is basically your discharge, which is rate with which water is coming out of the tank. So it is changing with time and the volume of water is decreasing. So minus dV by dt. So Q is equal to minus A dH by dt. Okay, and P1 minus P2 can be replaced as H rho G is equal to minus R A H, sorry, R A. Okay, so basically your H rho G plus A R dH by dt is equal to 0. So this is the natural response of the system. Now you have forced response. So in forced response, you are forcing the water to come out of this water tank. Okay. So you are supplying a liquid at a discharge rate of Q1 in order to maintain the water level, but due to this hole, the water is coming out at a discharge rate of Q2. You have pressure P1, P2, and the differential height is H. So this we have done in our previous class in hydraulic system model. So your we have done this in previous class. So it is rho gh is equal to AR dH by dt is equal to Q1. So this derivation you can see in your previous class. We have covered this one. Okay, so this is a force response. Next comes the transient oblique or sorry transient or steady state. So transient response basically it occurs whenever there is a change in input and it dies away with due course of time. So first understand this. You have a spring, okay, and you add some weight. So what will happen? Immediately when the weight is added, okay, when weight is added, the spring will immediately encounter the displacement. Okay, so input will increase immediately and it will vary with due course of time and it will die away with the time and your steady state is reached. Okay, so basically what is happening when you added the weight, immediately the spring will go down and it will settle down to a steady state after a certain interval of time, let's say t. So the region where this input is changing, this is your transient state. Okay, and the region or the point from which the transient state is died away. Okay, so it is your steady state. Okay, next comes the inputs. Okay, next comes the inputs. So first input is your step input. Okay, so in step input the input will remain constant for the rest of the time after when it is added. Let's say this is your response, this is t. So when at time t is equal to t1, you have added one input in a step and it will remain constant. Okay, it will remain constant for the further interval of time after when it is added. So it will remain constant. Then you have a sorry, which should be like this constant. Then you have a impulse input. Okay, impulse input. So you will, as the name suggests, impulse means for a short duration of time. So you will add an input for a shorter duration of time. Then you have a ramp input where the input is steadily increasing. So you have, this is your impulse input and this is your ramp input which is steadily increasing with due course of time. Then you have a sinusoidal input. Okay, sinusoidal input which is okay, which is defined as a function of in terms of sine wave. So you are adding an interval as a function of sine wave, which is represented by y is equal to k sine omega t. Okay. Now comes the different type of system which can be developed by the combination of dynamic, responsive, and input. So first we will deal with a first order system. First we will deal with a first order system. So basically a first order system is represented by a first order derivative with respect to time. So if your x is the input of which is varying with time, and y is the output which is varying a time with time, so it can be represented as bx is equal to a dy by dt plus a1 a0, okay, into y. So this is a first order system equation. So based on the input, your response equation can be developed. So first we will have a natural response. So in a natural response, your x means input is 0. So your output is naturally occurring. So means input 0 and you are getting output yt, and this is your system. Okay. So what you will get, a1 dy by dt is equal to a0 y is equal to 0 because your input is 0. So you rearrange this equation, it will be a0 by a1 into dt. Okay. Now you can easily differentiate on the both sides, and y is equal to e a1. Okay. So this is the response equation for natural system. Okay. Likewise, you have a forced response. So in forced response, your x will not be equal to 0. So you have bx is equal to a1 dy by dt is equal to a plus a0 y. Okay. So your input y is basically a combination of u plus v, means the steady component and the transient component. Okay. So you can place this and you can get an equation in terms of, okay. Okay. So the derivation for this is not important. You have to consider various consideration here, where at x is equal to 0, t is equal to 0, v is equal to a, you have to consider. But that is not important. Okay, that is not relevant for you. But you understand this. Finally, you will get an equation in terms of x is equal to steady state value into, okay. So this steady state value is dependent upon the type of input. Let's say you have step, ramp, or sinusoidal. Okay. So based on this, you will get the value. Okay. Next is your second order system. Yeah. Next is your second order system. So basically represented by second order differential equation. Okay. So example of a second order system is spring, mass element, and a damping system. It's a prime example of a second order system. So likewise, let's understand the different type of responses. So first you have a natural response. Okay. So in natural response, let's say you have a spring and a mass element A. Okay. So in this you have two. So in this you have two situations. One is undamped where there is no damping element, and another one is damped. Okay. But in case of natural response, if the mass is uh, tied at the end of the spring, what will happen? If it is no damping will be there, so it will freely oscillate. Okay. So the x can be represented as a sine omega t. Okay. And if you think about the differential equation of this above system, m is equal to dx per dt, that we have solved. Okay. C dx by dt. C is the damping element, is equal plus kx is equal to 0, because you are dealing with natural response, so input is 0. So and you have undamped, means the damping element is not there, so it is 0. Okay. Now, so what you will get? Dx square by dt square is equal to omega n sin omega t. First differential of sin omega t is omega cos omega t. Okay, and second differential again you will go, it will be minus a square sin omega, sorry, minus wn sin omega t. Wait, I will do it yes, so you can understand. Yeah. So dx by dt is equal to a omega n sin omega t, and dx square by dt square is equal to minus a omega n square cos sin t. Okay. So wn minus a sin omega t is x. So omega. Okay. Dx square by dt square, d square x by dt square is equal to minus omega n square x. Okay. Now, if you consider undamped system, so ma is equal to minus kx, and m d square x by dt square is equal to minus kx. Okay. So basically, minus k by m x is equal to minus omega n square. So omega n square is equal to k by m. Okay. So this is for your uh, undamped system. Now, when you have a damped system where the damping element is there, so m dx square by dt square is equal to c dx by dt plus kx is equal to 0. Okay. So in order to solve this equation, we have to consider a form. Okay. So where xn is considered, we'll consider xn as a e power st. Okay. Now you differentiate it. So what you will get? Dxn by considering xn is equal to, so dxn by dt is equal to a s, okay, and dx square. Okay. Now, so what will be the modified equation after assumption a square c a power st a e power st is equal to, so you take a and e power st is equal to common, to take it as common, so ms square plus cs plus k is equal to 0. Okay, so this type of equation you will get. Okay, and when we will cover Laplace transform in coming classes, you will understand that how this equation came. Okay, so instead of that assumption, you can directly consider this equation, that is ms square plus cs plus k. Okay, so now this type of quadratic equation solution will be s is equal to minus c plus minus C square 4mk upon 2m. It comes from minus b plus minus b square minus 4ac upon 2a. Okay. So from there we are getting, okay, so the root of equation. Now arrange this one. So c power 2m plus minus c by 2m plus minus c square by 4mk into k power k upon m minus k upon. So k upon m is omega n square and c square upon 4mk is equal to psi. So this is your damping factor. Okay, this is your damping factor. So in vibration also you have you might have studied this or you will study this one. So finally the equation will be damping factor times omega n under root damping factor square minus 1. Now as it is a damped system, so you will encounter different damping situation. First is over damp. Okay, first is over damp, that is where damping factor is greater than 1. So you have two roots s1 s2 which will be okay. Next is your, so the general solution for this equation will be x a s t. Next is your critically damped, where epsilon damping factor is equal to 1. So S1 is equal to S2 is equal to minus omega n. So the response will be Xn At plus B. Okay. Third is your, you have covered over dam, critically dam. The third situation is under dam, where damping factor is less than 1. So in less than 1, you have this imaginary value will come under root minus 1, which is iota. Okay. So you can replace it. S is equal to iota omega n 1 minus damping factor square. Okay. So omega n under root 1 minus damping square is equal, can be considered as omega. Okay. So you will have two solutions S1 S2, that is omega n iota omega omega n minus iota omega. Okay. So these are the two solutions, and general solution form will be xn is equal to e cos omega t plus q sin omega t. Okay. So this is the second order system with natural response having damping and with no damping. Okay. Next is your force system. Okay. In force system you have m dx square by dt square is equal to dx by dt plus kx is equal to f, because you are having an input in terms of force. Okay, so x will be x natural plus x force. Okay, so you will have t m plus c by dt plus kx and plus c f. Okay, so this natural component is considered as 0 when you are having a step input. Okay, so this whole term will be 0. We are considering step input for your understanding. Okay. Okay, okay. So for a step input, when t is equal to 0, xf is equal to a, which is a constant. So differentiation of the constant will be 0. So what you are having, ka is equal to f, and your a will be f by k. Okay. So xf is equal to, you can consider f by k. So general form equation will be a s1t plus b s2t plus f. So a general solution equation will be different for the different system. It will be for overdamped. Likewise, you can have a for critically damped, but this is not relevant for you. But just for a sake of your knowledge, I am telling you. Okay, although this portion won't be asked, uh, but the above portion is this uh, second order system natural response is uh, explained because if you see this one, yeah, this equation is uh, very important in case we will be covering one transient state problem where we will be uh, uh, discussing peak time over slope time. So that type of numerical can be asked during your examination. So in order to deduce that derivation, this was covered. Okay, other things are not that much relevant. You can go through it, but I cannot directly give you formulas without explaining the things. Okay, so that's why I gave you a brief idea how the things can be done. But the important from where the important thing which we will considering for you, we will cover in our next class. I think this much dose is sufficient for you for today. Okay. If you have any doubt, you can ask. Otherwise, we can end our lecture here. Okay. So, how many of you are back in campus? I have met with few. Kalyan, you are back or
I will come in 2 days.
okay? Okay. So for mid, you went back.
Yes, sir.
Okay. Anyone else?
Some
With
students
Laya?
are there.
Yeah, yeah. With Laya, I have met, but I think by 10th or so, you all will be here.
Yes, sir. By 11th, we will all be there in college.
Biswal, what about you? You are here?
Amarnath is not here, not in college.
Okay, okay. Piyusha?
Pisha also not
Yes,
there.
sir. I'm coming on Monday,
So,
sir.
okay, Monday. Okay, today is Wednesday. Okay. So yes, in coming few days we will meet definitely. Okay.
Yes, sir.
So we can end our class here. Okay. Is it fine?
Yes, sir. Fine, sir.
Yeah. Thank you all. Take care of yourself. Okay.
Yes, thank you.
Okay. Okay. Bye.